So a function is a relation where every x has exactly one y. So we're going to go ahead and look at our function analogy first. So for our function analogy, it says consider the domain. Now, a domain means this is our x value. So consider the domain to be a set of people on a bus. Think of each bus stop along the way as the range. Now your range, this is y. The function of the bus is to deliver people to their respective destinations. It is possible for two or more people to get off at one bus stop. However, it is not possible for the same person to get off at two different bus stops. Once you get off the bus, you're off the bus. So a person X is associated with only one bus stop. So that's for our function analogy. Then we're going to go ahead and go over here to the ordered pairs / tables. So here it says if a set of data is a function, each x value is paired with a unique y value. So in other words, to put it simply, your x's do not repeat. They cannot repeat. So we're going to look here at functions. Functions first, and we're going to look at the ordered pairs. So whenever you are looking at ordered pairs, you need to look at only the x value. Now remember, in an ordered pair, it's always x comma y. So here I'm worried about looking at the x's, and I need to make sure that they do not repeat. So here I have 3, 4, -2, and 0 for my x values. Here we see that all of my x values are different. None of them repeat, which make this a function. Now looking at our not a function example. Looking at my x's again, I have 3, 3, and -2. Here I see that my 3's repeat themselves. So since I have x values that repeat, this makes this not a function. So that's ordered pairs. Again, make sure you only look at the x values. Now, one thing I do want to mention is a common misconception is whenever you look at your y values. If you look over here for not a function, right here, I have my y value as 2, and here I also have a y value of 2. A common misconception is that people see that your y values repeat themselves, so some people would put this as not a function. But again, your y values can repeat. The only thing that cannot repeat are your x values. So now let's go ahead and look at tables. So on tables, remember you have been given an x column and you have also been given a y column. You are only concerned with looking at the x column. So that's going to be this column right here. And you are only wanting to look and you're checking to see if any of your x values repeat. So here I have -2, 0, 3, and 4. Here I see that none of my x values repeat, so this lets me know that this is a function. Again, you are not concerned with your y values, only your x values. So this is a function. Let's look at our next table. And again, I'm only concerned with looking at the x values. I do not care about looking at the y's. So here we're going to go ahead and check our x's. I have -2, 0, 3, and 3. Here I see that I have my 3's repeating, which lets me know that this is not a function. So that is for ordered pairs and tables. Next, we're going to go ahead and look at graphs. So for graphs, if a set of data is a function, a vertical line, and remember, vertical means it goes up and down, we'll cross the graph of the data in only one point. So looking at our first graph here, I'm going to go ahead and draw a vertical line. So this is called the vertical line test. So what we're going to do, we're going to draw lines going up and down and seeing how many times it goes through my graph. Now, since this is a scatter plot, here I see it only goes through one point. So this passes the vertical line test. I look at the next point. I draw a vertical line. I see it only passes through one point. Again, I draw a vertical line. I see it only passes through one point. Again, draw another vertical line going through another point. Again, I see here that on this graph, it goes through 4 different points. So this is going to be a function. Looking at our next graph, this is an example of not a function. So again, we're going to go ahead and draw and do the vertical line test. So starting from the left, I'm going to go ahead and draw my first line. Here I see that it passes through one point, so this passes the vertical line test. Looking at my next point, I'm going to draw a line. I see that it passes the vertical line test because it only goes through one point. And then going here, I see that my vertical line goes through 2 different points. So this does not pass the vertical line test, and this is not a function. Moving on to mappings. So for a mapping, it says if a set of data is a function, each element of the domain is paired with only one element of the range. So looking here at my functions, I have domains on one side and ranges on the other side. So here, what a mapping does is it pairs your x's with your y values. So here I have an x, which is 3, and it is paired with a y value, which is 2. So if I were to write this as an ordered pair, this would be 3, 2. Then if I look at my x value of 4, I have 4 being paired with 2. If I continue, I see that I have -2 being paired with 3. And then lastly, I have 0 being paired with 0. So then I can see here and look at my x's. I have 3, 4, -2, and 0. Here I see I have all different x values, so this lets me know that this is an example of a function. Now looking at our next mapping, I have 2 lines coming from one x value. So I have 3 being paired with 2. And I also have 3 being paired with 3. I also have -2 being paired with 0. And I also have 0 being paired with -1. So then if we go ahead and look at our x's, I have 3, 3, -2, and 0. Here we see that I have my 3's repeating themselves, so this lets me know that this is not a function. Now, a quick way for you to know and check to see if a mapping is a function or not. If you look here, you have 2 lines coming from one x value. If you have 2 lines coming from one of your domain values, one of your x values, this lets you know that this is not a function. That's an automatic way you know that it's not a function. However, if you go ahead and look at the example for a function, you will see 2 lines coming from one y value. That is okay for you to have, but you cannot have 2 lines coming from one x value. So that's going to go ahead and be the front page. We're going to go ahead and look at the back for a couple more examples. So here it says, are the following examples a function? So we're going to look here at number 1, and we're looking at ordered pairs. So remember, when we're looking at ordered pairs to determine if they are functions, we are looking at the x values. So here I have -4, 5, 0, 1, 8, and -2. Here I see that none of my x values repeat, so this is going to be a function. I'm going to put an F for function. Remember, it is okay if your y values repeat. It is not okay if your x values repeat. And here none of them repeat, so this is a function. Okay, looking at number 2, I'm trying to determine if the table is a function. Remember, we're only concerned with the x values. I do not care about the y values. You can go ahead and cross that side out, and we're going to go ahead and look at our x values. So here I have 2, 4, 6, 8, and 10. Here we see that all of our x values are different, so this lets us know that this is a function. Okay, let's go ahead and look at number 3. This is a mapping. So here I see that I have 2 lines coming from one x value. So that lets me know that I have 4 being paired with -3, and I also have 4 being paired with -1. Then I have 5 being paired with -1. I also have 5 being paired with 0. Then I see I have 6 being paired with 0. And I also have 6 being paired with 5. So then we look here, I have 2 4s, I have 2 5s, and 2 x's for my x values. So here I see that these are all repeating themselves, so this lets me know that this is also not a function. But again, you could have automatically been able to tell that this was not a function because you have 2 lines coming from your x value, you have 2 y's. You have 2 y values coming from 1 x value for 5, and then you have 2 y values coming from 1 x value for 6. So again, this mapping is an example of not a function because you have 2 lines coming from 1 x value. Okay, then we look at number 4. Number 4 is a graph, and remember we determine if a graph is a function by doing the vertical line test. So we draw lines going up and down our graph. We have one line here, it only crosses our graph one time, so that passes the vertical line test. I draw another line, this passes the vertical line test. I draw another line, this passes the vertical line test. So number 4 is going to be a function. Now, whenever you do the vertical line test, I would like to note that you can draw it wherever you want on this graph. It does not matter where you put it. Okay, then let's go ahead and look at number 5. So for number 5, we have another graph. So again, we want to see, does it pass the vertical line test? So drawing my vertical line, I see that it passes the vertical line test here. I'm going to draw another line. I see that it also passes the vertical line test there. I draw another line. I see again that it passes the vertical line test. And I draw another vertical line, and again, I see it passes there as well. So here, when I did the vertical line test, I see that it passes. So this is an example of a function. So I'm going to put an F. Okay, number 6 says, which domain would make the list of ordered pairs a function? So here, the only value that they have given us is 3. So I'm trying to look at my answer choices at the bottom and determine which ones would make this a function. So if I look at A, they've given me the values 2, 3, and 9. If I were to put these values into my ordered pairs here, this 3 would make this not a function because they have already given me a value of 3. So we can go ahead and cross out A. Looking at B, they've given me 7 and 5. Well, I have 3 open spaces, so that means that I would have to repeat a value. So there's not enough numbers for this in order to be a function. Looking at C, they've given me 1, 3, and 5. Again, they've given me one of my x values as 3, and if I were to put C and fill this in for my my ordered pairs, this 3 would make this not a function, so C is incorrect. 3. If I were to put 5, 1, and 4 into my ordered pairs, this would be a function because none of your x values repeat. So D is one of your answers. Looking at E, they have given me x values of 2, 2, and 8. Just alone, because they have repeated the 2's, this lets you know that E is not possible to be a function because since your x values repeat, it would make it not a function. Looking at F, they've given us 2, -5, and -3. If we were to put 2, 5, and -3 into our ordered pairs up top, I have 2, 5, 3, and -3. Here I see that none of my x values repeat, so that lets me know that F would also be an example of a function. Okay, so that is your video going over functions.